Hello. Um, I'm just doing a presentation on what I did for the Do or Die project. Um, it's called the Great Pi Vote. And so, kind of what did I do? So I built a machine learning model which predicts how many votes a contestant could receive on a Pi that they're planning on submitting. And so I wanted to talk about just the architecture and kind of like the plan I had while I was building this before diving into like the code and the real specifics of what I did. So first off, kind of the technology stack I used. I primarily used Python for the machine learning models. I used scikit-learn for that, and then I used pandas and matplotlib to kind of support what I needed. I also used Firebase and JavaScript to host data on a database. That way, there's multiple ways I can get data to run my models on. So here's kind of the basic flow of information. So to start off, I generate just a bunch of fake data with Excel, and I export that as a CSV file. And I either directly put the CSV into my Python machine learning pipeline, or I uploaded it to a NoSQL database with a website I have previously made. Then this Python pipeline, depending on what commands I give it, it will call some cloud functions to receive the data, or it'll just use the data from a local CSV, which I've provided the path for. So just kind of depending on how fluid / scalable I want this pipeline to be, it can perform different. It can perform differently. Once I've trained the machine learning model, I export that as a pickle file to main.py, which is just a little application I made to kind of demonstrate the predictability of this machine learning model in action. So here's just a few lines of JavaScript I wrote to connect the database I have in the cloud to my Python scripts. And it basically is just running on a GET request, and you'll see that later in my code. So just shortly before jumping in, I just wanted to go over what machine learning is kind of briefly, and how I used it for this problem. So machine learning is basically using computers to make decisions, or to help us make decisions. And in this case, we wanted to know how many votes someone could get depending on the type of pie they're making and where the baker's from. And I used two different models to do that. So, we can use different types of models or algorithms to try to fit our data. And basically what we're doing is we're trying to make our prediction look as close to the actual as possible. So over here on these two graphs, you can see the orange. The orange is our predicted values, and the blue is the actual value. So over here, we have an MLR model I made, and it had an average error of 81 votes. So on average, it's going to be off by 81 votes. And you can see it even dips down into the negatives. That's just kind of how this model works. And so it didn't see that, you can't have negative votes. And so that's why it's off by so much. And you might say there's some bias here because it always appears to be around 80 lower than it should be. Over here we have CART, which is like a decision tree model, and it was able to model the actual data a lot better. You can see the orange is a lot closer to the blue, and it doesn't actually ever go below 0. Which is really nice. And its average error is only 11 votes. So this just kind of shows how you can use different models to fit the data differently. If there could be times where an MLR is actually a lot better than CART. But for this situation, my CART model was the most effective. Here's just another demonstration. So CART is orange, MLR is green, and blue is the actual. You can see that the orange is a lot closer to the blue than the green is. Okay, now I'm going to go through a walkthrough of kind of the code I did specifically with machine learning. And this is just kind of a walkthrough of my own pipeline. So basically, this is the URL I'm calling to get data from a database. And then I just have a flag set here to say if I want to use the data from the database or if I want to use data from just like a local CSV file. For this pipeline, I'm actually using just from local CSV. Here is kind of the data. We've got ID, owner name, the type of pie they submitted, the number of votes that pie got, the traditional country of the baker, and whether or not this is a family favorite pie. I had to do some data conversions. Votes need to be an integer, and family favorite also need to be an integer. Other than that, it's looking good. And before I started diving into the machine learning algorithms, I wanted to understand my data a little bit better. So here are just some graphs that kind of point out. As we can see, there does appear to be a very significant difference between the number of votes you get for a family favorite pie and the number of votes you get for a non-family favorite pie. So it looks like if your pie is a family favorite, you're going to get a lot more votes than if it's not a family favorite, which I thought was kind of interesting. Over here, we're looking at how many votes each country got. It kind of looks about the same. Doesn't look like there's any countries that are really struggling. Here's just another representation of that. This is the amount of pies by country of origin for baker. So we can see England had the most pies, USA had the least, but it's pretty evenly distributed. There is not very much difference between the number of pies each country was submitted. And here it is again, just as a pie chart. So who won the competition? And I actually wanted to see who the top 50 were. We can see that the first, second, and third place go to people from England: Neville Merck, Fred Merck, and Fred Merck. And all of them were family favorites. In fact, as you can see, all of these top 50 are family favorites. But it's not just England that's crushing. We've got Germany, Canada, Germany, China, USA is kind of in the top, 20. So it kind of really looks like maybe it's the pie type, as everyone's doing spaghetti pie. So people really like spaghetti pie apparently, and then also if it's a family favorite. Over here we can see the amount of votes each type of pie got. We can see spaghetti pie got 21.8% of the votes. Pot pie got 20% of the votes, and pumpkin pie only got 3.47. So don't submit a pumpkin pie to this competition. You'd probably be best submitting a spaghetti pie. And we can just see the percentage of votes that each person got. Kind of looks like Walls Fred got 51%. But it's mostly pretty evenly distributed and kind of seems random to me. Okay, so with that, we've kind of looked at the data. We're starting to see some trends. So now we're going to start into the machine learning algorithms. So the first one I tried was MLR, multiple linear regression. And this is just me getting the data ready. I had to, of course, partition the data with training data, validation data, and so forth. Kind of the results of my MLR, just first off, we got an R-squared of 0.769 or 0.767, that seems pretty good to me. Adjusted R-squared is 0.766, so that means we're not really biased or anything. This is really good to have. And over here, if we look at our validation data, we got an R-squared of 0.765 and an average error of 80. And so, yeah, it seems kind of okay. And for a while, I just thought, hey, this is a great model. I'm not going to do anything else until I decided to kind of plot the actual versus predicted and just see kind of visually what's going on. And I realized that my prediction orange is it's always lower than what the actual is, and it's even dropping down to the negative. So I was kind of thinking, man, maybe MLR is not the right model for me to use. So I decided to try CART. It's just a decision tree model. And so I set it up, kind of did I fit it and whatnot, got our predictions. And here's a graph of the CART versus the MLR. CART is orange, MLR is green, actual is blue. And as you can see, the CART did a lot better. And so now that I've got a kind of a model that's a lot closer to the actual data, I'm ready to export that model as a pickle file and then use that to perform predictions. And this is the code I wrote to kind of make these predictions possible. And it's just really long. I was kind of lazy, so there's nothing really recursive going on here. If I wanted to make a function, I probably could have, but I didn't want to think about it. So it's just, not the best code ever, but it gets the job done. Anyway, so you can see we're importing pickle file, and we're using it. I called it MLR, but it's really just the machine learning model that we're using. It's CART in this case. And basically, I get data from the user, and then I run a prediction from the imported pickle file. And so I'm just going to demonstrate how that works right now. I'm going to let it load here. And so kind of while this is loading, just to kind of drive home the point of these predictive models I've made. So while I'm using this model in kind of a console environment, it'd be very easy to plug this into a RESTful API and have that kind of add this to your own website. So that way, if I have a website where people are submitting pies and they want to guess at how well their pie is going to go, they could use my machine learning model to do that. And I might show that at a later point. Anyway, so let's enter the app. And it says select the country you most identify with. So I noticed that England was doing really well. So I'm going to say that I'm from England. Select your pie type. Spaghetti pie seemed really, really good. So I'm going to use spaghetti pie, number 6. Is your pie a family favorite? It totally is. And so we got our predicted votes as 497. Now I'm going to do it again just to kind of show the machine learning model at work here. So let's say I'm from the USA, and I'm going to make the most American pie there is, which is a pumpkin pie. And is a family favorite? No, not really. My family doesn't really like or any kind of pie, really. So it's not a family favorite. And I got a predicted votes of 74. So, and I think that's actually going to be very close to what the actual data is, or what people who are from America and did a pumpkin pie and are not a family favorite probably got around 74 votes. Anyways, this is what I did for the Do or Die project. Yeah, feel free to contact me if you have any questions. I just kind of threw this together really quickly, so Sorry if the presentation is a little bit rusty. But yeah, this was really fun, and I'm looking forward to the next project that we have.